this function and maximum value of this function. Okay, minimum and maximum of these functions. Who can tell me what is the minimum value of this function?
0.
0. Absolutely correct. Very good. And maximum?
Infinity.
Infinity. Very good. Right? If you put minus infinite, it will make it positive, so infinite, but the least can be 0. Okay, so mod x has the minimum value as 0 and maximum value as infinite. Okay, let's do one more question. F of x is equal to mod x plus 2 minus 5. Okay, so mod x is from 0 to infinite, right? And minus 5. So the least value of this complete function would be minus 5 to infinite. Okay. Yes or no, everyone?
Yes.
All right. What is the maximum and minimum of sine 2x plus 2?
So do we use the range in this?
Sorry, what?
Do we use the range of the sine function?
Yes. The range of sine function is
Minus 1, 1.
minus 1 to 1. So minimum is minus 1, maximum is 1. If you add 2 to this, so minimum becomes 1 and maximum becomes 3. This will be the answer. Okay.
Yes, sir.
All of you, this is clear? Okay. Sine 4x plus 3. Minimum and maximum of this function. Okay, same way sine 4x would be from -1 to 1. If you add 3, it will be from 2 to 1 or 2 to 4. And if you make it positive, it still is 2 to 4. Okay, this will be the answer. All right, everyone.
Yes, sir.
Okay, so this is minima and maxima of a function without using differentiation. Okay, there are few things where you can use the basic common sense and find the maximum value and minimum value. Okay, but sometimes we have to use differentiation to find maximum and minimum value of a function. Okay, all right. So let's say this is 3, 6. Can say this is 5, 4, 3.5, 8, and again 3.5, and then is 5.5. Okay, this is the values of this points. Okay, this we can say is 5.5. This we can say is 5.3 or something. So this function is attaining different values at different axes, right? This is suppose x is 1, this is x is 3 and 5, 7, 9, 11, 13, 15, and 17. Okay. So at x equals to 1, f of 1 is 3. F of 3 would be 6. F of 5 would be 5.3 and so on. Okay. F of 13 would be 8. All right. This thing is clear what the graph is saying?
Yes, sir.
Yes or no, everyone? Okay. So what is the maximum value of this function? If you look at the graph, what is the maximum value of this function? 8. Absolutely correct. Rishita, all of you, is this clear? Zaina, Taha, Sufyan, Zara,
Yes, sir. Yes, sir.
right? The maximum point of this graph is this point, which is the 8. Okay, so the maximum value is 8. What is the minimum value of this function? Okay, very good, Rishita. Zara, what is the minimum value of this function? 3. And what at x, what value? We are getting 3?
1.
1. Absolutely correct. Very good, Zaina. So the function is attaining maximum value at x equals to 13 and the value is 8. Minimum value, which is x equals to 1 at x equals to 1 and y is 3. Okay. These things are called global maxima and global minima. Okay. Global maxima and global minima. That means overall in the complete function, that is the maximum value. But if you look at this point, this small point, this one, this is also a maximum point in its neighborhood. Yes or no? If you only draw this much graph, then this point is a maximum value. Yes or no? Yes or no,
Yes, sir.
everyone?
Yes, sir.
Same way, if
Yes,
you plot this much, this is a local minima. Okay, this is the minimum value. These kind of things is called local minima and local maxima, which are highest point in its neighborhood. This point, suppose I say name A is maximum in its neighborhood, not in the complete function, but it is the highest in its neighborhood. Same way, this point B is minimum in its neighborhood. Okay, so these kind of things are called local minima and local maximum. Okay, yes or no?
yes, sir.
Yes, sir.
Okay, so the complete information that we have right now is a function can have two types of maxima and two types of minima, global and local. Global is if you consider every point in its domain, then the maximum value is global maxima, and the values at which it is the maximum in its neighborhood, then it is called the local maximum. Same with the minima. Okay, everyone understood?
Yes,
Yes,
sir.
sir.
Okay, you can note it down if you want. Second. Wait, it's not responding. Just a second. Okay, note down. Local maxima and local minima. Let f be a real valued function and c be an interior point in the domain of f. Then c is called a point of local maxima if there is an h greater than 0 such that f of c is greater than f of x for all x belonging to c minus s c plus h. Okay, we're taking some point. What this means is, if you look at this point, this is x equals to 3. So if there is some h, which is suppose 0.3, then 3 minus 0.3 and 3 plus 0.3. This value f of 3 is maximum in this range, right? So this thing will be called local maximum. Same way, C is called point of local minima if there is an h greater than 0 such that f of c is less than f of x for all x belonging to c minus h, c plus h. Note it down. Okay, the first point is C is called a point of local maxima if there is an h greater than 0 such that f of c is greater than f of x for all x belongs to c minus h to c plus h. Noted, everyone?
Yes, sir.
Okay. Notes. If point has local maxima or local minima at C, x equals to C, then either f dash C is equals to 0 or f is not differentiable at C. Okay. If it is a local maxima or minima, then it must be, the differentiation must be 0 or may not be differentiation, may not be differentiable. Note 2. Converse of the above theorem is not true. Okay, what it means is, if a function is local maxima or local minima, then it must be either not differentiable at that point or differentiation must be 0. But that does not mean that if the function is not differentiable at C or the differentiation is 0, that means it is a local maxima. Every rectangle is a quadrilateral, but not every quadrilateral is a rectangle. Okay. Every samosa has aloo in it, but not everything that has aloo in it is a samosa. Understood, everyone?
Yes, sir.
Yes, sir.
Okay. Noted? Okay. Very important test, which is the second derivative test. If f dash c is 0 and f double dash c is negative, local minima if f dash c is 0 and f double dash c is greater than 0. Test fails may be a point of inflection if f dash c is equal to 0 and our f double dash c is also equal to 0. Note it down and explain this through a question. Third point is if f dash c is 0 and f double dash c is also 0, then this test fails. It may be a point of inflection. Point of inflection means a function like this. This might point of inflection, okay, where the curvature changes. This part is concave upwards. This part is concave downwards. So where it changes the concavity, it is called point of inflection. It is neither a maxima nor a minima. Okay. Okay. Done, everyone?
Yes, sir.
Question is find local maxima and local minima for f of x equals to 3x to the power 4 plus 4x cubed minus 12x square plus 12. Okay. So remember, this is same as finding increasing decreasing. First step, I'll give you a few steps. Okay. First step is to find f dash x and put it that as 0. Find c. C is the values of x or critical points where this function is 0. Second point, find f dash x. Okay. Find f dash c. These critical points you have to apply in that double differentiated function. For an example, don't write it, just listen to me. Okay, look at the screen. First we find f dash x. When we differentiate it, what will be the differentiation?
12x cubed plus 12x squared minus 24x.
Right. Now second step, what is the second step?
Differentiated again.
Okay. What will I get if I differentiate it again?
36x squared plus 24x minus 24.
Okay, so are we done? The question is complete. or did we skip few steps?
Mm.
We have to put this f dash x as 0, this thing as 0, right? Yes or no?
Yes, sir.
So 12x cube plus 12x square minus 24x will be 0. Okay, we have to factor it. Take 12 common. So x cube plus x square minus 2x is equal to 0. In fact, we can take x common. So x square plus x minus 2 is equal to 0. And this will be, I think, x plus 2 and x minus 1. Okay, is equal to 0. So critical points are x is 0, x is minus 2, x is 1. Yes, this is the value of C. Yes or no, everyone?
Yes, sir.
Now all we have to do is f dash 0, f double dash 0, f double dash minus 2, f double dash 1. We have already differentiated, so you have to put the values, these values, in this function. So if you find f double dash 0, it will be 0, 0, and minus 24. For minus 2, it is positive, right? 36 times 4 minus 48 minus 24. Yes. So this is 144 minus 2157. So 72, and f double dash 1 will be 36 plus 24 minus 24. So 36. Now if you look at the theorem, if f dash c is 0, that means at all these points, this is true, f dash c is 0 at all 3 points. Okay, and if f double dash at that point is negative, then at 0 or x equals to 0, we have a local maxima. All right, everyone?
Yes.
And where it is positive, we have a local minima. Okay. Yes,
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 sir.
sir.
note it down. Done, everyone?
Yes, sir. Yes, sir.
Yes.
Okay. All right. Understood it? No doubts?
Yes, sir.
Okay. Okay. Find local maxima and minima. Done, everyone? Okay, Zana. All right. So first step, let's find the differentiation. So 6x square minus 12x plus 6. Okay. Now we have to put that as 0. So we have 6x square minus 2x plus 1 is equal to 0. Plus 6, this is x minus 1 square equals to 0. Okay. So factors are x equals to 1. Okay, Zana. How did you get 0? 0 is not a factor, right? And if we double differentiate this, f double dash x will be 12x minus 12. So if you find f double dash 1, it is 0. So now we know that it is neither a maxima nor a minimum. Okay. Maybe a point of inflection at x equals to 1. Okay, everyone?
Yes, sir.
All right. Maxima and minima. Global maxima and global minima. Remember, if someone says find maxima and minima, they are talking about global maxima and global minima. Okay. That in the larger picture, in the complete function, which is the maximum value, which is the minimum value. Okay. So remember, it will always be in a given range. If you have to find the maximum and minimum value, that must be in a given range. It cannot be from infinite to infinite. Okay. So let real function defined on an interval a to b, then f of x is said to be or said to have maximum value in a to b. There exists a point c in AB such that f of x less than or equals to f of c for all x belongs to a to b. Okay. What they mean to say is very simply, when you are finding global maximum and global minima, all we have to do is find the local points, right? The same process as before, and find the endpoints also. Okay, if this is a and b, then find f of a and f of b also. Okay, check which value is the maximum value, which value is the minimum value, and you'll get the answer. Is it clear what I'm saying?
Yes, sir.
Right, find the critical points. Hit C, find f of c, find f of a, find f of b. Whichever is the maximum, that must be the maximum value. Whichever is the minimum, that must be the minimum value. Okay, note it down. find local maxima and local minima if any of the function f of x equals to sin x plus cos x, where x is from pi by 2 to 0. Okay. Okay. Done, anyone? Same steps. F dash x will be cos x minus sin x. Let's put that as 0. So we have tan x as 1. So x would be pi by 4 because x is from 0 to pi by 2. Okay, no other values. F double dash, we can find cos x minus sin x, and sin x is cos x. Let's find f double dash pi by 4. So minus sin pi by 4 minus cos pi by 4. So it will be negative. Minus 1 by root 2 minus 1 by root 2 2 root 2 minus root 2. Okay. So at x equals to pi by 4, we have a local maxima. Okay. Yes or no, everyone?
Yes, sir.
Okay, note it down. Find two numbers whose sum is 24 and whose product is as much as possible. Okay, that means maximum. These are called wood problems and finding maxima and minima. And remember, very important is to find what they are asking you to maximize. Okay, so find two numbers, we can say x and y. If you just translate this question in mathematics, you'll get the answer automatically. Two numbers x and y whose sum is 24. So one equation is x plus y is 24. Whose product is maximum? So let's say P, product is xy. We have to maximize this. So whoever we have to maximize will differentiate and use the technique in this function. Okay. One rule is to create this in a single variable. So we can write y equals to 24 minus x. So function becomes x times 24 minus x, which is 24x minus x square. All we have to do is find the maximum value of this function. So we can find the steps, differentiate, find critical points, double differentiate, put the values, get the answer. Yes? Yes or no, everyone?
Yes, sir.
Okay, please do. Okay, Zana. All right, let's see. We have P as 24x minus x square. So P dash will be 24 minus 2x, which is 0. So x will be 12. So P double dash will be minus 2, which is negative. Okay. So at x equals to 12, P is maximum. Okay. So x is 12. So y will be 12 also. So what it means is, if you have to see that two numbers, their sum must be 24 and product is maximum, the numbers you must choose is 12 and 12. If you take 10 and 14, then the product is 140. But here we are getting 144. No other combination is possible where product is more than 144. Okay? Yes or no, everyone understood?
Yes, sir.
Yes, sir.
Okay. Find two positive numbers x and y such that x plus y is 60 and y cube is maximum. Okay, same question. Done, everyone? Okay, we can write P is x y cube, which we have to maximize, which is the product. And we can find x is 60 minus y, right? Replace x, which is 16 minus y times y cube, which is 60y cube minus y to the power 4. So first we'll differentiate. So it is 180y square minus 4y cube. Okay. If we put this equals to 0, we can take 4 y square common. So it will be 45 minus y is equal to 0. So either y is 0 or y is 45. If y is 0, product becomes 0. So it doesn't work. Let's find p double dash. So it will be 360y minus 12y square. Okay. So here you can see 45 square and this is 45 360. It will be negative. You have to find the values, but I can say that this is negative. Okay. Yes or no, everyone?
Yes, sir.
Negative for 45. So at this value, this is maximum. So if y is 45, then x is 15. That means for a product of 60, for a sum of 60, these two numbers are possible where the product is maximum. Okay. Yes or no?
Yes, sir.
Yes, sir.
All right. Show that of all the rectangles inscribed in a given fixed circle, square has the maximum area. Okay, they are saying in a given fixed circle, that means there is a circle with a fixed radius. Okay, so that of all rectangles, that means no matter which kind of rectangle you draw, okay, you can draw infinite number of rectangles like this. Okay, they are saying prove that or show that of all the rectangles, square has the maximum area. When you draw a square, that must have the maximum area. The square has all sides equal. You have to show that. So you have to maximize the area of the rectangle, and that will give you the proof that it is a square. Yes or no, everyone understood the question?
Yes, sir.
Okay, I'll give you some hints. Okay, suppose this is the circle and this is the rectangle that we have to find the maximum area. Okay, this is r, this is r. Let's say this is x and this is y. From here we can say x square plus y square is 4r square, 2r whole square, Pythagoras theorem. Yes? Yes or no? Remember, r is a constant. And you have to maximize area, which is x times y. All right? So you can find y as 4r square minus x square root and replace here. I did the same thing. I wrote two equations. One we have to maximize, one which was given thing. One variable, I wrote it in the form of another, replaced it. Now all we have to do is differentiate, find critical points, double differentiate. Okay?
Yes, sir.
Okay, please do this. Solved, everyone? Okay, can we keep a extra class tomorrow? Yes or no, everyone?
Sir, at what time?
You tell the time whenever suits you.
Sir, I have 2 classes tomorrow.
2 classes tomorrow. If not even 1 hour, Rishita, possible?
Yes, that's fine.
That's fine. Okay. What time?
Sir, I'm free. Like 3 p.m., 4 p.m. Okay, fine. Yes.
3 p.m., 4 p.m. KSA. Okay. So 6:30 Indian time, you are saying IST
Yeah.
is fine. Okay. 5:30 or 6:30. All right. Is the time working for everyone?
Sir, I have a class from 4.
Let's make it
6:30
5:30. Okay. 3 to 4, 1 hour class. Yes. Yes or no, everyone?
Yes.
Okay. And what about Friday? Friday, anytime, even later night is fine. Friday, 8 p.m. KSA is available, everyone?
Sir, I cannot do that time.
Sorry, Zara, your voice is not clear.
Yes, sir, I was saying at night I cannot.
Okay. Rishita, you are also not available? Okay. What about Saturday?
May- Maybe in the evening it's okay.
Okay. Saturday? Are you guys available Saturday?
Yes, sir.
So I won't be available on Saturday.
Anytime? Zaina?
No, sir, I'll be out of town.
Sunday also?
Friday I can take a class.
Friday you can take a class. Okay. Any way we can make a class on Friday or Saturday, guys? Who is up for Friday? Raise your hands.
So Friday 3-4 p.m. it's okay, but later I cannot.
Okay, 3-4 p.m. is okay. Okay, all right. Rishita, Friday is fine for you? 3-4 p.m.
Yes, sir. Yes, sir. Early is fine.
Okay, so 3-4 p.m. KSA you are saying, right?
Yes, sir.
Okay, so 6:30 IST. Okay, I'm writing this on chat. Just say yes. Okay. 2 extra classes tomorrow. Thursday. Three p.m. KSA. Friday also. Friday 3 p.m. is also fine. Everyone.
Yes, sir.
Yes, sir.
Yes.
Okay, so let's keep it the same time. Okay, just say yes, sir, or okay, and I'll get it marked. Okay. I need everyone's reply. Zara, I did not get your reply.
Yeah, I said okay. I think. Message.
Okay, please. No, I did not receive. I think you sent it to direct message someone else or Learnivio team. Send it to me.
Oh,
Okay.
okay.
Okay. All right. This question, who has solved, who has not? Okay, we have got A as x root 4r square minus x square. Okay, just differentiate it. Okay. So A is x root 4r square minus x square. If you differentiate it, A dash or dA by dx, you have to use product rule. So differentiation of x is 1. So 1 times root 4r square minus x square plus x times differentiation of this will use chain rule 2 times root 4r square minus x square and differentiation of minus x square, which is minus 2x, and this is gone. Okay, if you simplify and cross multiply, this will be 4r square minus x square upon root 4r square minus x square. This is 4r square minus 2x square upon root 4r square minus x square. Okay, yes or no, everyone?
Yes, sir.
And when you put at this as 0, you get 4r square minus 2x square as 0, or x square is equals to 2r square, and x is equals to plus minus root 2r. Okay, obviously cannot be negative, so positive root 2r. Okay, we have to differentiate again to verify whether it is maxima or minima. Okay, double differentiate and put root 2r, you will see that it is negative, so it is maxima. If x is root 2r, you can calculate y also. Y is 4r square minus x square root. So 4r square minus x square, which is root 2r square, 2r square root. So 2r square root, which is again root 2r. So x is equals to y is equals to root 2r. So rectangle is a square. Yes, everyone?
Yes.
But you cannot write like this. You have to double differentiate this function. which is dA by dx is 4r square minus 2x square upon root 4r square minus x square. We have to double differentiate and show that this is maxima. So d square y upon dx square will be u by v form. So root 4r square minus x square times this is minus 4x, okay, minus 4r square minus 2x square times differentiation of this denominator upon 2 root 4r square minus x square times minus 2x whole divided by square of this thing 4r square minus x square. Okay, so this 2 and 2 is gone, negative becomes positive. Now we have to put x as root 2r. So if you put root 2r here, this is positive, negative. Okay, 2 to 4, this is 0 and this is positive. So overall it becomes negative. Let me show you. 4r square minus root 2r square root times minus 4 root 2 r plus 0 upon 4r square minus 2r square, which is 2r square. Okay, so you can see it is less than 0. So it is maxima at x equals to root 2r. Understood, everyone?
Yes, sir.
Yes or no? Okay, note it down from starting to end. Very important question, and this type of questions are very frequent in exams. Note it down. Done, everyone?
Yes, sir.
Okay. Any doubts? Any doubts? Yes or no?
No, sir.
Okay. All right, then this is all for today's class. See you tomorrow, guys. Take care. Okay. Do the homework.
Thank you, sir. Nice.
Yeah. Bye bye.